have to make, or just any candy dispenser for you?
So yeah, there is no specific type of candy dispenser. This is your concept and your design. So
Oh yeah. So
all yeah. So all I recommend is, or that I require is that it has mechanisms to dispense the candy. So it can't just be, like I said, a pull-out drawer. Um, yes, that's a mechanism. However, that's not the kind of mechanism that we're thinking of. Um, there are no limitations. Well, there's some limitations on the size of the candy dispenser, but the big, and again, later today, we'll cover all the details. We'll bring it up and we'll measure our candy too. So that way you'll have some data points to start to work with with
I
the candy
I
dispenser.
was looking yesterday. I was looking at. Do you know the candy dispenser, the one they sometimes put it in the stores, like it's
Yeah,
holding gums, and you put the quarter, and it goes around. It's
yep,
like, yeah, you know what I'm talking about, Tom?
absolutely.
Yeah, that was I'm looking for. Like, I was thinking to do this for you.
So the candy, all right, since we're talking about it, I might as well we'll continue to go. Let me share my screen and let's see here. Bingo. Share. All right, so now you can see the candy dispenser project that's under week 14. Yes, I
Hmm.
know that it's a couple of weeks away, week 14 technically. Um, this is kind of the best part of the whole class is that we've got a couple of extra flexible weeks in here um, that usually we're 3D printing and we're focusing on things in that realm. Unfortunately, we don't have that capability live right now. Um, and so uh, actually I'm gonna okay I'm gonna go ahead and okay, perfect. um, and so with that flexibility we have a little bit more time we can attribute to the um, candy dispenser. So here's the deal. The candy dispenser is a product that you're going to design. This particular product technically is a 50th anniversary product for a company, and so they're a candy company that makes different candies. They then want to create a 50th anniversary dispenser. Now, um, the idea is that this particular candy dispenser, and again, I do not want you to go out to buy candy just for this project. We could come up with a variety of different candy components. So case number one, do not go out and buy candy. Somewhere in, like I said, I just dug up three different candies in my household here, and others can dig up other candies that we can measure for the project. So you don't necessarily have to go out and buy the candy. The best part is you don't have to model the candy, so you don't have to create 3D models of the peanut M&Ms or of the Werther's Originals or the Lifesaver, unless of course you want to, but that's not a requirement of the project. You have to reverse engineer at least two candies. Okay, so we're probably going to scale that back to having one candy. I'll provide you the M&M sizing. We could probably do the Lifesaver sizing, and then you're going to have to come up with at least one of your other candies that you're going to dispense and measure on your own. This is the reverse engineering project that I typically have the online class focus on, where they actually take apart a kitchen utensil or other object and measure it and design it. And we can do that, and I have no problem with that. And that might actually be a really good project to do on Fusion as a test project. But pick something simple like a spatula or a spoon that may have multiple parts. Um, that's an assembly, but that's another opportunity if you wanted to practice within the Fusion environment. All right, so this particular candy dispenser needs to be easily cleaned. We don't want, a bunch of candy grunge on the inside of the dispenser. So it has to be able to be taken apart. So it's going to be in multiple pieces overall. You're going to dispense 3 of these candies, as we indicated, and it kind of lists that there could be all different types of candies, and it depends, like I said, what you may have in your household and available to you. I guess we could expand it and have it, have it dispense like blueberries or blackberries or something like that too. If we really had that and we had no other candies available, we could use different components that we could dispense. You can't just make a candy up. The candies have to be real. So that's part of this requirement, is that you do have to measure things to make this project accurate. So besides being easily cleaned, you have to have storage area for the candy. Now, there's 2 different directions you can go with this. You can pour all the candy into one hopper, which is not a sanitary, or you can have 3 separate hoppers, one for each of the candy types. And that's your call on how you might want to do that. If you pour everything into one hopper, then there should be a way to choose the type of candy you would like. So it's like, again, you're just not pulling open a drawer and okay, we've got 3 M&Ms and a Lifesaver and a Werther's Original in there. Well, what if I only wanted the Lifesaver? I don't need all the other candy to be dispensed at the same time. So you'd have to somehow figure out how to choose specific candies from that single hopper. Or you can have 3 separate hoppers and dispense each hopper individually. The mechanism can be the same for all dispensers. So if you do 3 separate hoppers, you could use the same mechanism on each of the hoppers, which is an advantage that you can accomplish. Should hold about a 6-ounce bag of candy. That's a small bag of candy. Doesn't have to be that large. Okay. Again, the footprint of this is about 12 by 12 by 12. I've gone up as large as 15 by 15 by 15. It's got to be a tabletop. So if we set the footprint to 15 inches by 15 inches by 15 inches. Now, why did I pick 12 by 12 by 12? Because our 3D printer maximum size is 12 by 12 by 12. And we were 3D printing some of these parts as part of the class. So we put that limitation on the size. You have to have a minimum of 8 parts. Okay, you have to have a minimum of 8 parts, and this includes the mechanism and the storage area. So you've got to think about, well, how are we going to have 8 parts associated with this? And the moving parts are used as a mechanism. So what's your deliverable? Well, the deliverable no later than April 29th. Okay, April 29th is the final day to turn this in. Is that you need to create a similar drawing packet like you did with the ArborPress. It's going to be a PDF packet, except this time it's got to be all your drawings of all 8 parts or more, depending upon how many parts you may have, an exploded assembly, and an assembled assembly. Now, I also ask, and we could either do this live, which I'd like to do. This would be a really good Zoom opportunity. What we can do is we can actually do Zoom presentations live and have you present live your candy dispenser to everybody on the 27th, on that Monday, and then your final documentation is due on the 29th. So on the 27th, we can either A, do live presentations, or B, you're going to have to submit a separate presentation and rendered imaging and so forth. And so part of this project is that you have to sell your design. As we talked about earlier in class, you could have the best design ever. If you can't sell your design to other designers and to other manufacturing and to the advertising people and to the administrative people, it will never get built. So you've got to go through this design review, and your design sales process. You have to be able to sell your design. And since we're in a small group, we can do that live via Zoom on Monday the 27th. And you could have either a PowerPoint if you wanted to, or you could just have some of the drawings that you've created and go through the drawings and talk about it. It makes no difference. But the idea is that we'd like you to do a short presentation on why your candy dispenser works extremely well. Whew. So that's the candy dispenser project. We've got roughly 3 weeks to get it done. And it may, seem really huge, but it's only a minimum of 8 pieces. Now you might decide that you have 12 or 14 pieces on your design. That's why I wanted you to have a concept between now and, let's say, Monday. We'll have just a rough sketch. Just kind of sketch something out on a piece of paper. Here's what I'm thinking on my design, and it's going to change. Okay, we're not going to hold you to your concept design, but I want you to start thinking about this and get moving. If you don't get moving now, it's going to be a week and a half later, and it's going to be like, oh man, I got this project to do, and I've got to get it done, and I don't have enough time. So we're going to get you pushed a little bit faster on this project. So we're going to move faster. So the goal is that Monday, I got to find my chat window again. My chat window went away. There we go. So Monday, have a sketch and share your concept. Okay, and so those are the key dates. Now, between now and then, we're going to use the class to either talk about how to create specific types of objects. Like, for example, if you want me to go over how to create springs again, I'd be happy to talk about how to create a spring, or how to create an auger. I don't think we've talked about how to create augers and springs yet. That's on my list of things to talk about, and that may actually start to happen today too, after we talk about the caster. But maybe Monday we'll talk about springs and augers, because augers work really well to move product around. If you think about it, you use augers to move corn and soybeans and other bulk products from one part to another. You also use it to move liquids from one area to another for mixing purposes and so forth. If you watch, you can even watch on YouTube how it's made from the Science Channel shows. You'll see augers all over the place. If you're going to coat donuts with chocolate, you use an auger to spread that chocolate material across the area that the donuts will be drizzling under. Those are types of tools that you can use an auger for in terms of moving the product. Well, guess what? You could use an auger to move candy too. There's a variety of different concepts and ideas. You can make it a fun dispenser where it's kind of like a toy and a dispenser. You can just make it a dispenser to where it's just a dispenser. There's no limitations, as you can see, on what the concept design is or the model itself. This is totally your design. Couple of reasons why I have this project in here. Number one, I want you to create a project and a design that you can call your own, that you can share when you go on an interview. Besides the ArborPress, which is an impressive project that you've created, you'll want to have a second project that you can also share and talk totally about on how the product works and how the design is put together. That in itself will help you cinch a position in a junior design kind of job or a detailer kind of job, that kind of work environment. So those are important tasks and important skill sets. that you'll possess once we're finished with our project. Questions on the project as I've kind of laid it out and it's on the screen?
So
The
far,
only
so good.
thing that worries me is coming up with the dimensions for what the parts will be, because I don't know just how I would go about that, making everything fit.
Yeah, that's part of the whole process of design. You're going to have to sketch some things out and kind of get an idea of how big objects are. That's where you know, grabbing your ruler or your set of calipers or other objects that you know, if you've got a ruler at home, that's all you need is a ruler. Doesn't have to be anything special, but it'll help you spatially see how big 12 by 12 by 12 is, or 15 by 15 by 15. You know, if you think about it, a sheet of paper, let's grab this one, is 8.5 by 11. That much we do know. So, you know, this is 11 inches long. So 11 by 11 is almost the 12 by 12 size, to give you a spatial concept of how big the footprint is of the object.
Okay.
You know, so you've got to start thinking about, all right, so what's 12 by 12? Well, maybe there's some containers in the kitchen that you have that you can measure to say, oh, wow, this one's 6 by 6. How does that fit with the 12 by 12? To start to get that spatial ideology.
Alrighty.
Other questions? Okay. All right. So what I'll do is I will switch over my share to Fusion. Cool. All right. So you should be able to see the Fusion now, from the Fusion design. All right. So I've got two components that we created, or the on Monday we created the top plate and the arm, and we were in the process of assembling them. And so I think this is about where we left off on Monday with the caster project in the Fusion environment. And so the assembled caster on my video has got a really basic wheel. We're going to make this a much jazzier wheel. We're not going to, you know, we've got to step it up a bit. But I just created a simple circle and extrude just to show the process. But we'll jazz up our wheel a little bit more. And so the big thing that you need to remember about Fusion, as we've talked about before, is that you have two types of objects. You've got bodies, and then you've got the components. And so the components have the blocks, and those are those items that you can assemble. Bodies are objects, and so those you cannot assemble. They're the sub aspect of, either like the top plate has a body, but then once I change it to a component, that component now can be assembled with other components. So yeah, Jason had a question on chat about that he has no candy in the house, which is fine. So at the end of class today, or towards the end of class, we're going to go ahead and we'll live measure these Werther Originals and the Lifesavers and the M&Ms. So I've got my calipers set up. We're ready to go for the measurement side of the process. So after we're done with the demo on Fusion, we can work with that. So again, if you haven't installed Fusion, I would definitely install Fusion as a software. You don't have to uninstall Inventor. You can install Fusion next to it. And it doesn't take up that much space because most of Fusion is done on Amazon web servers. So this is actually run through an Amazon web server environment. You've got a small package that's in your computer, but most of the heavy processing and graphics are done outside of the software or off of your computer. All right, so this is where we left off on Monday. One of the things that we can do, and we can right mouse click and we can change appearances of objects. And so the appearance tab allows us to put colors, and this is significantly better than the Inventor tools in terms of the different colors and appearance components you can apply to this particular object. So on our top plate, as you can see, we've got a variety of different capabilities. We can put a fabric, glass, leather and cloth, liquids, metal, mirrors, miscellaneous. Let's see, air. Ooh, that's pretty miscellaneous. Other that didn't fit, and base metal, environmental, gemstones, rubber, water. So the deal is that these are not only used here in Fusion, but they're also used in other software tools like Revit, and which is building and the building environment. So Revit is like Inventor and Fusion for the architectural construction trade. So if you want to put a specific color on a house or shingles, and so you have to have a variety of different capabilities. Paint, plastic, stone, and wood, and solid wood. So there's a variety of different capability. You know, like you could do granite, blue, pearl. And so remember how I got here. I right mouse clicked on this browser listing to get to the appearance of the object. So instead of just doing a face, I'm doing the whole object. And if we slide the granite blue, I'm going to go ahead and drop it up here first. And you can see that it put the actual product on here. Now it doesn't look very good, but you can tell that it is totally different than the other objects. A lot of times metal looks really good, plastic looks good. If you choose plastic, there's a variety of different plastics. You can do transparent, translucents. Many times I'll just do the basic paint colors. And you can do glossy paint, metal flake, metallic paint, powder coats. So you can do rough or smooth powder coats. Okay, is everybody familiar with the powder coat? What a powder coat is? Yes, no? Type in chat.
I've seen what it looks like, but as far as how you go about it, I mean, I don't really know.
Okay, of how powder coating is done.
Yeah.
Okay.
Or like, don't they bake it or something like that?
Powder coat is baked after the initial application. Basically, you're electrifying particles. And so the object is negative, the particles are positive, so they attract to the object. Once the particles are on the object, it's then baked into a finish. And so you can do rough powder coats or you can do smooth powder coats. Typically, powder coats have a texture to it. They're not perfectly smooth. But you can see that you can then put glossy paints and so forth. And if we were to do a rendering of this, we would actually see gloss and reflectivity. If you put a mirror finish on it or a chrome finish, you would have that process also. So the cool thing is that we can choose different appearances for each object. And so I can select the arms and say I want to do, let's say red metal flake. Let's see here. Something's not happy. Let me right mouse click. I have to exit out of that, and then I can do the red metal flake. It's not happy with red metal flake. Glossy red. It loves glossy red, but we're not red metal flake. Not sure why. So notice that I only applied it to one arm, but both arms have the color. Why is that?
Is that because you mirrored it?
I copied it, yeah. So I copied the object. And so since it's a copy, it maintains that specification. All right, so now we have to create the wheel and the pin, or the shaft that goes through this. And so let's think about how we can create a really cool looking wheel. The best way to do this was probably through a revolve process. And so like any design, we have to start with a sketch, and we can choose one of the base areas to create that sketch. So I'm going to choose this orientation as the sketch. For the wheel, we know that the wheel size is 2.5 inches in diameter by 3/4 of an inch wide. So what I'm going to do is we're going to go ahead and create a shape here. Let's see if we go here, come across, come out, come straight up, come back, and I'll draw a line here. So that line is going to be a construction line. If you remember, we right mouse click, choose construction. That's like my center line now. And that's going to be the wheel shape overall. So we know that the diameter of the hole, I just cut those, undo. All right. The diameter of the hole from let me go ahead and tilt this just a little bit. So the diameter of the shaft hole is 1/4 inch. So the distance from the center line to the bottom of the object needs to be 1/8 of an inch. Why is that? We're going to revolve the shape. So if this is 1/8 of an inch and it gets revolved, we'll have another 1/8 of an inch on the bottom. Does that make sense?
Yeah.
Distance from here to here has got to be 1/2 of, so it needs to be 2.5 divided by 2. So 2.5 inches divided by 2. And we can create some really cool geometry here. So if we grab this, and we can change the size of the shape of the object yet. And we can even delete this line if we wanted to and create something even more wild. Because there are no rules. Okay, so this is going to be one interesting looking wheel. So we're going to dimension this. We'll make this 115 degrees. We'll match that to this side. So those are the same. We'll put this angle in here. That's 165. We'll see how this angle matches up. Not bad, 165. And then we're going to dimension this point as 0.50. And we'll dimension this point as 0.50. All right, so things are coming along now. Now that we notice how the reason why I did that is I wanted to make sure that the angles held stable and that the object is centered. So now you can tell that it's still not 100% centered yet. So this is 1 inch wide. Well, we know that it's got to be 0.75 is the overall width. Uh-oh, that's not good. Let's undo that because that's no longer going to provide the distance that we need. So a 1/2 inch here, we'll say 0.375 here on the bottom. That kind of went awry. Grab this data point, kind of smooth this around to make that still look the same. And then from here, ooh, how are we going to do this? So we got that, we got that. That's, I got to undo. There we go. So we have to hold some smaller dimensions in place before we do the larger dimensions. So let's go ahead and put these in. 0.25, 0.25. We have that dimension in as a 1/2 inch already. Let's go ahead and put this dimension in. We'll have all these verticals set up. So it'll over constrain the sketch. Interesting. I think I made it more difficult than I really needed. 1.25, okay. So I'm going to make these two equal. So this and this need to be equal. And wonder if I do this and this is equal, what will happen? One error, failed to solve. Okay. So you can't make those equal currently. So that's there. All right, so now I'm going to need to put a dimension in here. So it's a pretty stable shape because I'm not able to change data points. So we've got those dimensions, that's fine, except it's not centered. And so I'm going to need to center this because the minute I change this down to 0.75, it's going to have an issue, but that's okay. Wow, it's telling me that it's going to over constrain that. All right, so let's delete out. We have that. So when it says that things are not constraining, what's happening is that we've tightened this up too much. And so we have to determine where we might need to have some flexibility in the design for it to flex. And the other option is that, there we go, we missed this dimension here. So this 0.625 needs to change. Let's see if that opens this up. There we go. So that 0.75 to that, that's a 1/4 inch. Half of that is 0.125. Bingo. So that one dimension that we had prohibited the centering of the shape. That actually looks really good now. All right. So now we've got our shape overall. That was an educational experience in itself. We'll finish the sketch. We'll revolve it. And we need to pick the axis. That's what's in blue. And there's our wheel. Much cooler of a wheel than just a simple circle. So we have our wheel. And if you wanted to, you could actually cut this out and make spokes and the whole deal if you really wanted to go to the next level. And now we have to create the shaft. So here's the deal with the shaft. What is the distance that we need to extrude the shaft so it doesn't stick out beyond the 2 arms? Oh, by the way, this particular body, body 3, we need to call it wheel. What do we need to do with a body to make it addressable in assembly? Change it to a component. We need to change it to a component. So now that becomes a component wheel. All right. The final thing that we have to deal with is the shaft. And so we need to actually measure from the outside to the outside. And that tells us that it's 1.125 inches between the 2 openings. So now we need to create the 1/4 inch shaft at 1.125. So we can create a new sketch. Doesn't matter which way we want to go. We'll put it here. We'll draw the circle. We know that the diameter of the circle is 0.25. And we'll extrude the circle. Doesn't matter which way we extrude it. No. 1.125. All right. So body 4. And let's go ahead and change the appearance. And thank you, Anya, for letting me know that I needed to download the metal flake. Downloadable material features will be re-enabled. So after Fusion finishes the live update and restarts. So I'm going to go. Okay, thank you. So we're going to go ahead and we'll create that as a yellow. What color wheels do we want? So we have a mahogany wheel, which looks kind of sharp. All right, so now that we've got all the appearance components done, we've got everything up. The shaft needs to be created as a component. So we need to take the shaft and let's go ahead and choose OK to finish the colors and change the shaft into a component. So now all these are components, which means that we can use the joint tool to orient and position that. So again, when we're dealing with the Fusion environment, let's go ahead and put the wheel in place. So we're going to use the joint tool. Again, we can create new components, top line, or we can just create a body and turn it into a component. Both work. Now we can create the joint. And if you remember, the joint capability is all about positioning. So if I'm going to pick the center edge of this wheel, and we're going to align it to the inside of the opening. That's the joint. We want to connect those 2 points, but then we're going to provide it an offset. And we got a position. Why am I in a simple joint? Okay, one selected, one selected. What just happened? Simple, 2-edge intersection, position, component 1, wheel, component 2. There we go. Component 1, component 2. And then I have to give it an offset, but I have to know which direction. Well, the easiest way is just to look at the arrows and drag it. And so I need to drag it over to the center to center this wheel. And it's kind of hard to see, but you can see the opening gap. Okay, and so I can drag it and say, oh, well, that's going to work because it's in the middle. So it's 0.2. Well, we know, and if we do the calculator math here, you can't see the giant calculator on my screen, but I've got a calculator up. 1.125 was the opening of the outside. We know that each one of the thicknesses of the arms are 0.125 or 1/8 of an inch. So we're going to subtract 0.25. Okay, that leaves us with 0.875 as the opening minus the wheel width, which is 0.75. That leaves us with a 0.125, and we divide that by 2 because we want an equal distance on both sides. So in essence, our gap, if everything is designed properly, is 0.0625. Too many points in there. But that doesn't look right. Now, why is that's not correct? Because it looks like it picked the outside edge as opposed to the inside edge. So we're going to need to add the thickness of the arm. Does that make sense? The issue was that I picked the wrong spot for the joint. I picked the outside edge and not the inside edge. And so if I did the math said it's only supposed to be a 1/16 of an inch gap. Well, the problem was that the 1/16 of an inch gap, which is 0.0625, was based on the inside of the arm, not on the outside. Well, since I picked the outside, I have to add the thickness of the arm, which is 1/8 of an inch, which is 0.125. And then when I choose OK, it's now perfectly centered. The shaft is actually quite easy to join. We pick the joint, we pick the edge middle, we pick the edge middle, and it provides the object. Now, the joints that I've positioned here are all rigid. There's no motion involved. If I was to use the wheel and position this wheel in a different type of joint, I would have to change this from a simple, let's see here. If I change that, there was an option here to animate this joint. Yeah, see how it just shakes it because it's a rigid joint. Okay. And so, thank you. So since it's a rigid joint, I would have to edit the joint and make it a motion joint. And this one would be a revolute joint because we'd want it to be able to spin. Did everybody see that?
Yeah.
We'll animate it again.
Yeah.
So instead of just doing it as a set position, we can make it a motion joint with a revolute, and the rotation is, you can choose which axis you're going to rotate it around. This one happened to be the z-axis. And we'll choose OK. So now the wheel is flexible. We can animate that wheel if we needed to with that design. So now our caster is put together. We want to save it. And we'll call this assembled caster 2, or assembled caster wood wheel. And so now that'll update our design in our listing. Now comes the fun part. We have to do an exploded assembly. This is our assembled assembly, obviously, right? And so now we have to do an exploded assembly. And the thing is with exploded assemblies, if you remember, like in Inventor, we'd go to the presentation tool and create the exploded assembly. Well, here we do the animation tool to do an exploded assembly. So like the presentation tool, this is kind of a combination animator and exploded assembly. So if we were to disassemble this, what would I want to move first?
Would it either be like the top plate or the cylinder that goes through the wheel?
So that would be the shaft.
Yeah.
So think about how you would actually assemble this. So if you were to put this together, because obviously the top plate and the arms are connected together. So that's one piece. So if you were to assemble the wheel and the pin or the shaft, you'd put the wheel in place and then you'd push the shaft into place. So to disassemble it, we'd have to remove the shaft and then move the wheel. Fair enough. So we'd want to disassemble the same way. Now on the bottom, it's going to give us a timeline that we can do all these with. And this is as easy as the Inventor process. In some cases, it's even easier. What you can do is notice that on my browser, I just hit the arrows to make all the parts visible. Why? Because it's easier for me to pick the part from the list than it is to go in here and zoom in and try to find it. So if I need to move the shaft, I'm going to pick transform the component, which is move. I'm going to pick the shaft, and notice now I've got arrows. Well, for me to move the shaft, I need to slide the shaft out of the way. And so I'm going to slide it, and we'll slide it 4.0 inches. And we'll choose OK. So now on the bottom, it's now given us a movement, and in 5 seconds, it's going to move the shaft 4 inches. Okay. We'll play with some other things here in just a minute. So now I've got to move the wheel. So I got to move the wheel either straight out or down. So I'm going to transform the wheel, and I'm going to do both, but I'm not going to do both at the same time. So I'm going to transform it with one move out. And so this is going to be a negative because I went against the direction of the arrow, 3.0, and we'll choose OK. And now we'll transform the wheel down a negative 2 inches. Okay, and so with the wheel, again, it only did it in 5 seconds, so that's gigantic. So I can expand these into a longer period of time. Or that was 1 second. Okay, so I'm going to move this wheel. It's going to move the wheel in 8 seconds. It's going to move the shaft in 5 seconds. So now when I hit the play button, everything's assembled. We hit the play button. Uh-oh. The wheel shouldn't be moving when the shaft is moving. That's not accurate. Let's see that again. Okay, so notice that the shaft needs to move first before the wheel. So I'm going to need to make sure that the wheel doesn't start until 2 seconds in. So in essence, I'm actually creating a live animation. Now notice that the wheel moved diagonal. It didn't move straight and then down. Even though I did a straight move and then a down move, this moves diagonal because it was all in one movement set. Now we can edit these. So we can go back and edit these particular movements. So for example, I can change and edit this action and say, no, I only want to move it straight up first. All right, now I can do a second transform, select my component, and then do a second transform down that 2 inches. So the wheel is still not giving me 2 movements, it's giving me 1 movement. Interesting. Yep, still giving me 1 movement. But you have to think about, how does the part come up, how does this assembly come apart? From here, we can then, if we wanted to do callouts, we could do callouts to add text associated with this. You can also change camera positions. You can publish it, so you can actually export this video as a MP4, that kind of thing, so you can post it to YouTube. But this is how we create our animation. Once we're done with the animation, okay, we're going to use the storyboard. Now we have to create the drawings. So let me stop and ask if there's any questions on the animation transformation component.
That was pretty simple.
Yeah, it's actually easier than Inventor. Process is the same.
It's nice that you don't have to go back out and start a new assembly or start a new presentation. You can just do it right from the same screen.
Yeah, and it's and you have complete editing capability here.
Yep.
And if you notice, my initial moves with the camera changing the view, the direction of view, is also captured as part of this. So I can actually drag this out also. So that camera view that we changed, as this rotates around, you can create some pretty impressive capabilities. How to make an impressive video. All right, so now that we have this completed, I'm going to hit the save button again. Version description is animation, and choose OK, or I can choose milestone, and this is our 4th milestone, but I can choose animation, so it's just going to save the animation as the version. Notice that every time it comes up with a new version and it tells me what I previously saved as. This is awesome to be able to go back and say, oh man, I messed that up. I can go back to the assembly, or I can go back to the wood wheel and go back and manipulate it and change it. So you've got all the version history right in front of you. The last step that we have is creating drawings. And so when we create drawings, we can either create drawings from design or from animation. Well, if we grab the animation, it's going to be an exploded view. So that's how we get our exploded view drawing into our drawing set is we choose drawing from animation. So let's go ahead and do that. So we're going to grab the animation drawing, and I did this really quickly on Monday at the end of class, but so we're going to create the drawing from the storyboard. It's going to be a new ASME is how we're going to dimension it. Units are in inches, and it's a B-size sheet of paper, so you can choose A, B, C, D, E, or A, B, C, D, or E for mechanical drawings. So we'll do a B-size sheet. We'll choose OK. So the sheet will come up. It's working. So we have our sheet, and now it has our animation, which is our exploded view. The deal, though, is I can pick my point here, so it's going to be my animation. I can change the scale. Do I want a 1-to-1 scale? Yeah, that actually isn't bad. I can change the orientation also. And again, I'm working from the dialog box here. So I can change the orientation to different modes. Do I want to look from the bottom? There's the northeast isometric that I was at. There's the northwest isometric. So the northwest isometric is probably the best. Okay, so I'm not going to worry that the wheel is off the paper right now. I'm going to be able to move this particular view here in just a second. Once I choose OK, I can grab this point and shift the actual location of the object. I can also change how it looks. So I can shade the object, or I can shade the object with hidden edges so you can see the back sides of things. Typically on the exploded view, you just want to shade the object, and we'll choose OK. So now I can take, and I should be able to grab and move the image to make it fit on the paper. So I can place the view, and there we have it. So far, so good, right? Now we need to create the parts list and balloons, because that goes along with the exploded view. So up across the top, we have tables, and it's got a balloon next to it. So the table obviously represents the parts list. And so we can choose the parts list. It wants us to pick the drawing that the parts list is coming from. And so the drawing is our select drawing view. It only has one view. And so we're going to go ahead and pick where we want this parts list on the drawing. When you place the parts list, it automatically places the balloons. Again, everything can be moved and edited with these balloons. So you can customize the positions of all the balloons. So that way they're not in a straight line and they look like they were custom created. So you can grab and move those. Can we edit the parts list? Absolutely. If we right mouse click on the parts list, we can edit the parts list itself. If we annotation. All right, so we're in new territory here because I have never edited the parts list yet. So if we go annotation, now that's to create annotation. So if we create this, right mouse click, projected edit view, repeat table, tables, balloon, bend identifier, renumber, align balloons. Okay, interesting. So those are basically the table options. Shift and toggle for, so there's got to be a way to edit this. And if I double click on it, there we go. I just double click on it. I can take the description out if I don't want the description to make the parts list smaller. If we wanted to put the description in, we would have to put a description in each one of the parts for it to appear. But basically, I just double clicked on it. And by the way, the wheel is not steel because I didn't change the material in each of the parts. They maintain their default, which is a steel. If I wanted to, I'd have to go back to the wheel, which I can, and edit that. All right. That worked out well overall. I can slide that over. All right. So now we've got to do the assembled view over on this side. To do the assembled view, I'm going to do a new base view, but the base view is the model. Okay, so let me slide this out of the way. So the base view is the model, it's not the storyboard. So we're going to choose the model, and we can also do this at 1:1. We'll see if we can make this fit perfect. And then I can change the orientation again to northwest isometric. Perfect. So it's in the same orientation as the exploded view, and we'll keep it shaded. So there you have it. We now have our first drawing sheet completed. The exploded view and the assembled view. Editing the title block, it's going to bring in your name because that's what you've logged. You can go ahead and edit the title block information. We could create a new title block, so it won't allow us to edit the title block. If we can add additional text to this, but this is default. So the project is the folder that you've created. In this case, my folder is called class instruction. The title is top plate. Well, the title isn't really top plate. We really wanted, so title top plate. We really wanted to make this caster. So I would have to actually edit and add a new title block and edit from scratch the title block. Okay, so let's beyond where we want to go today. What we can do though is create our detail views. So creating our detail views, down at the bottom, there's a little plus sign here to quickly add another sheet. So let's say, for example, pick one of the parts that you want me to detail. Doesn't matter which part, just pick one of the parts.
The wheel.
Okay. So the wheel is part 3. And so we'll go ahead and produce the wheel. So we're going to do a base view, and we bring the base view in, and we're going to set this at 1:1. But it comes in as the model. And I don't want it visible edges, visible and hidden edges. We'll just do visible edges. So we want the model. Let me move this out of the way so we can see what's going to happen here. So I click on the model. And we do want visible edges, and we'll choose OK. But we don't need everything. So you want me just to do the wheel. What I have to do is turn off the other objects. And so the wheel is left. But I want hidden lines, so I'm going to have to edit the view. And so I'm going to go ahead and choose the visible and hidden edges. And so I'm now going to project from the front to the side. And now I've got my hidden edges, and I can project from the front to the isometric. And I can double click and edit this view and make it shaded. So that way that stays as shaded. So now I've got my wheel, but you saw how I had to edit this. So it brought in the whole model, which is the assembly, and I just turn off the pieces that I don't want to work with. Now I can use dimensions, and I've got a variety of different dimensions that I can use. Diameter, being 1. And I could do dimensions on all these different radius locations. And then I can do dimensions on different components. But it'd probably be better if I sectioned this so we could see some of the features. Now the question is, do I want to section it? Which direction do I want to section? Probably this way and do a top view.
That's what I would say.
You know, so I do a section view on this view, and then I'm going to have to find the middle. And so like Inventor, I have to draw the cutting plane line. Okay, and then I choose continue, right mouse click and continue. And I can project directly up or directly down. Okay, so realistically, we may have to shift these views around a little bit and adjust them, which is fine. And so we'll do the section. And again, from the parent, we want visible edges only because this is a section view. So we'll choose OK. So there's our section view. What's going to happen now is I'm going to need to move these views up to provide enough room Oh, come on now. I want you to move up.
That was doing that to me in Inventor.
Yeah, so here's the deal. I
Yeah,
think
I'll delete it.
it's
It's
there
like
we
stuck.
Yeah, no, I had to zoom up. That's all I had to do. Now that I moved it, we're going to be okay. Text, I might have to move and adjust a little bit tighter. So now I've got the section view. And with the section view, I can now add the additional dimensions that I need, the angular dimensions that we had placed. But you get the idea here on the different dimensions that I can place, not an aligned. I wanted to do an angled. So here to here. And then dimensions. I could draw in a center line between the two, dimension to the center line. So you get the idea that you can build and dimension each of these components. So we did it there. So from the center line to here, from the center line to here, from the center line to here, and then from the center line to there. And then you do the same thing on the widths. And so you have to do the width from one edge to here. That should be switched. We'll have to switch those. So to switch those, again, just like Inventor, we just kind of move these around. So now they're in again, making it look good. And then if there's other dimensions we need, we can add those to that. So you get the idea of how we can manage the drawing environment. What if we wanted to detail another product? Same thing. We hit the plus sign to create a new sheet, bring in the base view, 1-to-1. Visible edges. And let's say, for example, you detail the arm. Same thing. Project the views. Shade the view that you need to shade. And then you can detail out the arm. So it makes sense once you get used to how the drawing process works. It actually is pretty simple in how you can manage it. So, questions? Questions? He's looking in chat and he's looking, sounds good. All right, it's now 10 o'clock. We can take a break and then we've got some lab time. And during the lab time, once we get back from break, we'll take a 5-minute break. I'll be back by about 10:02, 10:03. I'm gonna go grab a drink of water. When we get back, we'll measure candy. So, and then we'll do candy measurements live. And I'm going to pause our recording. So we're recording again. If somebody could type in chat the measurements that I measure on these candies, so that way you've got it recorded also, would be a benefit. So we'll start off with the lifesavers. And I've got 2 different lifesavers. I've got one that has, I put some orange on it so we can identify that as the orange lifesaver versus the plain. Measurement wise, I'm going to get the measurements in millimeters, and that'll give us a fairly accurate measurement for us. Overall package size is going to be 52.2 is overall package size. So that's the plastic packaging. Vertical.
Did you say it was 55.2?
52.2 is our overall packaging size. So let's double check that.
Okay.
And we're going to do both of these, so you'll have a couple of data points to work with. Yeah, 52. And 52.2 is about the right size. We want to be super accurate. I got 52.23. Ooh, got to turn it this way. No. This is weird. Camera's backwards. That's wild. 52.23 is the exact size that I got. All right. On the height, and again, every time that I use the calipers, I zero it before I do a dimension. So this is packaging size. So the packaging size on the height is 30.6 millimeters. So if you did 31 millimeters, that would be appropriate. All right,
Okay.
now the physical product in size, I have 23.8. 23.8 is the diameter of the lifesaver. do we need to know the hole size? We'll see if I can get the hole size here. So using the top end of the calipers gives us the internal.
Okay, hold on. What was the diameter of the Lifesaver? Was it 20?
23.8.
Okay. And then now we're doing the hole.
Yeah, the inside hole size is 7.18 millimeters. 7.16, it looks like. Yep, 7.16 millimeters is the internal hole size. 7.2 would be a good compromise. I can push it a little bit farther and do 7.23, but a compromise between the two would be 7.2 millimeters. All right, I guess I got to eat this one now because it's opened. Let's check the overall size, the diameter of this Lifesaver. Overall diameter, 23.63 is what I got as
And I
an overall.
have 23.8 on the other one.
Right. So there's variability. So manufacturing wise, they're close. Yeah, 23.61 in one direction. $23.6566. So there's a little bit of variability in the Lifesaver diameter.
Now, do you want me to put both of those or just leave the ones that we have?
Well, you'd want to do an average of the two. So
Okay.
I would just do raw data and just say Lifesaver 1 is this diameter and Lifesaver 2 is that diameter. The packaging, you can, we could use just one packaging because the packaging is pretty consistent. Okay, the packaging size is extremely consistent when I match this up. It's the diameters of the candy is slightly off.
Did you say that the second one, was that one still 23 or was it 22?
23.66 was the diameter
Okay.
for number 2. The thickness of the Lifesaver is 7.98. So they're designed for 8 millimeters thickness. Let's see, 7.98. Let's see what the other one was. 8.08. So again, variability in the Lifesaver. I'll have to open up the M&Ms here because they're not even open yet.
Kind of messed up that I accidentally hit enter when I wasn't ready to.
Missed which one?
Just like the spacing's off. Because it says Lifesaver 2, and then it says 23.66, and then like there's a whole bunch of spaces, and then it says inside hole. And
Oh, inside hole was 7.16, or yeah, inside hole 7.2, 7.98808. Perfect. That looks good.
okay.
That looks fine. M&Ms. I'm going to pour out a few M&Ms here on my desk. Whoa. I will pick a large, a medium, and a small peanut M&M to dimension. All right. We have a large.
I can build M&Ms because by the time I get done with the project, they'll be gone.
But that's okay. As long as you got the measurement, you're good.
Oh, that's right.
You can eat as long as you got the measurement, you can eat the candy afterward. That's fine. That's part of the fun of having face-to-face class is that I actually bring the candy in, we measure it, and then we've got
Oh,
candy
you-
for I get bags of candy, so you get like candy for the next 2 weeks to keep you sugar motivated in the class. But unfortunately, in our remote learning environment, we don't have that sugar incentive. All right. Large M&M. Overall dimension is 14.15. So that's the height of the M&M. The width of the M&M.
Okay, hold on.
14.15.
Okay.
16.76. So 16.76. 77.
And what's that?
That would be the width. And then the length. Ooh. Come here. It's a good thing it's got a candy coating, or else the length would, or the size would change. I'm having a tough time getting, oh, there we go. No. Having a tough time capturing the physical length. There it is. All right. 23.75. Let's see if we can get that to show up. There we go. 23.75 on the length. That's the big M&M. A medium size M&M. We'll do the height. By the way, the height, I'm taking the M logo. Ooh, can't see that, but there's an M logo. So the M logo is, I'm measuring top to bottom from the M logos for the height. So the height is 14.38, 14.38, 39. All right. Width. $16.65. There we go, 16.65. And then the length, $18.99. So that's the medium size, and we'll do the small one. This is a really small one. Okay. Height of the small one, 13 point, there we go, 13.85. Excuse me, 13.82. My fault, 13.82 on the height. $13.10 on the width. And the length, $16.16. All right, so we've got M&Ms. Now, realistically, what we would do is we would all have M&Ms. We would all have objects that we would then measure, and we would find the average size for the large, medium, and small M&Ms in your packages. And if we use the non-peanut M&Ms, they would be very consistent in sizing, which is pretty interesting to work with. All right. Did you want the third object, the Werthers, or do you want to pick your own third object? I think we should let everybody pick their own third object. And if you don't have candy, you can measure blueberries, you can measure anything that would have a variable size associated with it and find an average, because it's not going to be perfect. And I know Jason indicated, or Josh indicated, he had jelly beans. That's fine.
The only thing
Go ahead.
that I really have is this gum,
Gum would work.
like the
Yeah,
Extra.
there you go. Perfect. The gum would be perfect. So gum would work. Any of that kind of thing would work. Even sticks of gum would work. You just got to figure out a way how to dispense a stick of gum. Not the package, but the individual sticks. So,
yeah.
you know, if you think about it, like if you had a stick of gum or Twizzlers or something in that way where it was packaged where, you know, there was no way that it would be a bulk item. If you go back, and you can actually Google this, so you could Google cigarette machines, or even the candy dispensers at the end of the hallway at Sinclair with the spiral coil that dispenses it, and you load those in. But candy and cigarette dispensers were the same design up until like the 1980s, 90s, and then they went to the spiral wheel process to dispense those products. So you could look at other ways to dispense products. On Monday, we'll go through how to create a coil and an auger. If I get time to practice in Fusion, I'll do it in Fusion. If not, we'll do it in Inventor, and Fusion will work similarly in that process. But if I get a chance, I'll play with it. If I don't have a chance, then we're going to do it in Inventor, and maybe next Wednesday then I'll get it
Would
into
you do it on
Fusion.
Fusion, please?
Can I do it in Fusion, please? Process will be the same. As you saw, designing and building things in Fusion is the same as it is in Inventor. It's just a matter of picking the proper tools. And there's probably a video out there on creating a spring or a coil already. But if I get a
Nice.
chance, I'll practice it.
Yeah, my point is because I just have access to Fusion anytime in my MacBook. You know what I mean?
Sure. Yeah, and Anya's only got Fusion also, and so you know, we're split between Inventor and Fusion within the class at this point, which is fine if we have the opportunity, and if I get a chance to play with it, I'll definitely do that. Worst case is that we'll do a demo on Inventor, and then we can try a demo in Fusion, and it may work and it may not work. You know, again, it's one of those we can learn together as a group. Is kind of the way that I'm looking at this. Because I won't
Appreciate you, Tom.
Yeah, I won't guarantee that it'll work the first time until we figure out how to do it. That's all I've got. It's 10:30 and we're finished. I'll stay live here as long as you want to stay live. You can get started. If you haven't done the diving board project, get that turned in. That's probably, you could get that finished between now and 11 o'clock, the diving board. If you do it in Fusion, we showed you how to do the Fusion simulation tools in Inventor. You've got the stress analysis tools, so you could get that diving board project completed between now and then.
I had a question on the diving board.
Yep.
When I started doing it, there's a big diagram of like the pool water and all that, all the depths and stuff.
Yep.
Any of that? Do we need to do all that stuff?
Well, part of learning how to design things is to determine exactly what you have to design. Now, the question that I have for you is that critical in finding the displacement of the diving board itself?
No,
No.
There's your answer.
I just didn't want to not do it or do it and waste time.
Well, but that's part of, again, determining exactly what they do this in math all the time, where you get this word problem and they throw in this extra bonus stuff which has no relevance to the actual problem.
Hmm.
Well, in this case, this is a design problem that I provided additional information that doesn't pertain directly to the problem. It pertains to the problem, but it doesn't help you solve the particular problem.
Right.
But if you're designing a pool, that's really important information.
Yeah, because you gotta know if you jump high enough and how far you would go down and all that stuff.
Well, exactly. And then because
You
your
don't
pool
let-
design has to meet those criteria, and that actually happened to be from New Mexico. So if you're designing pools in New Mexico, that's what it would be, the requirement. But that's the idea. Sometimes you're going to get information that you're going to go, like you questioned, is it really important to have? Well, what's really important is the diving board. So, but like I said, I'll stay live. And maybe I'll play in Fusion here. I won't share it, but I may play in Fusion and see if I can create a
When's
coil.
the micrometer test do?
So those are online. Those are just reading the prints. You want to get those done by next Monday.
Okay. Something to do this weekend.
So, yeah, because I basically offered them up on Monday, so you want to get those done within that week.
Right.
So timeline-wise.
So that's just the micrometer reading, and then it's like the tools and.
Yep. So you got the micrometer reading, you got the decimal inch reading, and then you've got the diving board. Those are all due on Monday.
I'm pretty sure I've finished all those.
Yeah. And then the next task will be our reverse engineering of our candy that you're going to be working on, and then starting it on your candy dispensers. And
On the diving board, I know there's 3 holes that hook it,
Mhm.
but on the map it shows like a triangle underneath the diving board.
Right.
So am I gonna fix it to that, or would I fix it to like the ground?
So when we did the plant hanger, you open up my plant hanger again, and
I remember you did that the one side to the wall, but this is a little different, right? Because we're not using an L bracket; we're using a flat.
Yeah. So there's my plant hanger, and what did I do? Is I fused it to the wall. So if you've got points, then maybe it's not a surface, because like the wall was a surface, right?
Right.
So that's a surface. So if it's not a surface, then all we can do is mount it based on the holes,
Okay.
because it doesn't have a surface that it's mounting to. It has points that it's mounting to. All right. Well, I'm going to stay live. I'll stop recording because we won't be presenting any new information. I may play. I'll try to play an inventor here while you guys are working and see if I can create a spring and/or an auger, and see if it works the exact same way, which I expect it to, because it has the ability to do coils. So I don't see why it wouldn't work exactly the same way as it does in Inventor. So that's what I'm going to do for the next 30 minutes. Is I'm going to try to play with coils and an auger. So we will see everybody bright and early on Monday for sure. But yeah, stick in here. And if you have run into a problem or a question, I'll be here to help answer it. And you've got one more item to measure, one more candy or other product that you're going to have to measure on your own to dispense. All right, I'm going to stop the recording.